Hello there, welcome to the AS Maths Applied June 2023 paper. Here we're looking at question 2. A small stone is projected vertically upwards with a speed of 39.2 meters per second from a point O. The stone is modelled as a particle moving freely under gravity when it is projected until it hits the ground 10 seconds later. Using the model, find the height of O above the ground. Okay, let's draw a little diagram to visualise what's gone on here. So the particle has started, we'll call it x meters above the ground, and it's been projected upwards and it's come down and hit the ground 10 seconds later. Its initial speed upwards was 39.2. So we know that u is going to equal 39.2. Okay, so let's start to do some SUVAC calculations. So S, U, V, A, and T. So its displacement is going to be minus x. The reason the displacement is minus x is I'm going to set upwards to be positive for this whole question, and if x is the difference between its start and finish point, and it's gone downwards, then s is minus x. U is going to be 39.2. Not interested in the velocity that it hits the ground at, so I'm going to leave that blank. The acceleration is minus 9.8 because upwards is positive and it's accelerating down to the ground, and it hits the ground 10 seconds later. So we're going to use S equals ut plus half at squared. So we're going to get minus x equals 39.2 times 10, add half times minus 9.8 times 10 squared. I'm going to put that all into the calculator. So 392 add 0.5 times minus 9.8 times 100, and we get minus 98. So x is therefore 98 meters. Okay, there we are. That's the answer to part A. The total length of time, as we define now, the total length of time for which the speed of the stone is less than or equal to 24.5. Find the total length of time for which the speed of the stone is less than or equal to 24.5. Okay, so there'll be a point in time that is higher than the original starting point where the particle has started to slow down so that the speed is now less than 24.5. So what we want to do here then is find the total time. So when we start our SUVAC calculations, we want to find this value for the time. So that's what we're going to be interested in. A is still going to be minus 9.8. U is still going to be 39.2. V is what we want to set as 24.5. So we'll find the time of that, and then we'll do the time of minus 24.5 and work out the difference between those two times. So V equals U plus AT. So we want to find out when it's 24.5 meters per second. When it starts at 39.2, add, we'll just subtract minus 9.8 t. So let's work that out. The time that it will hit 24.5 meters per second. 24.5 minus 39.2 divided by minus 9.8. And that gives us t equals 1.5. So that's the first time that it reaches a speed of 24.5. Then it starts to slow down, and then as it's coming on the way back, we'll need to do a calculation with v equals u plus at again, where the velocity is now minus 24.5. So that'd be 39.2 minus 9.8 t. Okay, so minus 24.5 minus 39.2, and then divide that by minus 9.8, will give us 6.5. So 6.5 seconds. Okay, so between the time of 1.5 seconds and 6.5 seconds, the velocity is less than 24.5. So the length of time, so the final answer for part B is 5 seconds. And there we are, that's the answer to part B. State one refinements that could make the model more accurate. It would make your answer to part A more accurate. Or we could take into account air resistance. That's the classic example. Air resistance, we could use a more accurate value of G. We could include some spin on the stone, include the shape of the stone, include the size of the stone, the wind effects, etc., etc. So anything that would make the answer more accurate. So there we are, that's the answer for question 2 with a total of 7 marks. Let's now go to question 3.